Hi everybody, David Peacock here. I'm in my old room right now, cleaning up some boxes, getting everything ready, since eventually I am going to be fully moved out of here. But today is a very exciting day. You all have been waiting for this all year. I hear nothing but, geometry, it's mean, geometry, mean. Well, guess what? Today, it's the geometric mean. This is geometry. All right, let's get straight into it. Geometric mean. So to start with, we actually need to talk a little bit about right triangle similarity. In a right triangle, an altitude drawn from the vertex of the right angle to the hypotenuse forms two right triangles. So if we just, in this case, the altitude that we're referring to is the altitude from C to D. And if you look, it creates a right triangle, this small one right here, and this small one right here. Now, here's the interesting thing. This triangle, and the big triangle are all similar. So they will have the same ratios, which makes kind of some sense because we have the 90-degree angle, and A is going to be the same as A for this triangle. And then B is going to be the same as B in this triangle. So we actually have AA similarity for both. But that ends up leading to some interesting things. So let's write a similarity statement for each of these triangles. So I would start with like RST. So triangle RST is going to be similar to, let's go with this small triangle right here. So we would say triangle R, because R is the same angle. But now S was the 90-degree angle in RST. So instead of saying RSP, we're going to say RP, and then the third angle would be S. Then we're also going to say RST is similar to, in this case, we're now going to say triangle. In this case, well, let's see. R is now a different angle, but we actually know T is going to stay the same. So I'm going to say T. Now S was the 90, and that is once again P. Why did I just put P? R. And which means we're going to say SPT. Now since these are both similar to RTS, we can also say the triangle RPS is going to be similar to triangle SPT. So there we go. Those are our similarity statements. And that ends up mattering because we'll actually be able to create some similarity things. Notice the P is in the middle, all of that. But to do that, we're going to need to know what geometric mean is. So here's what the geometric mean basically is. If I was to create a similarity statement where a ratio where A is to X as X is to B. If we wanted to solve this normally, we would cross multiply. So A times B is equal to X squared. And to get X by itself, we would square root both sides. So what we would find is the square root of A times B is X. And that is the geometric mean. The geometric mean is the square root of two numbers multiplied to each other. So whereas normal mean is like the number of numbers where we add them together and then we divide by how many numbers there were, with geometric mean it's we multiply the numbers and then we'll root by the number they are, in this case because it's square, by 2. So that's the geometric mean. All right, so let's try out some. Here's our first one, 4 and 9. So to do that, we would do 4 times 9, which is 36, and then we square root it, and that's 6. So the geometric mean of 4 and 9 is 6. What about 10 and 30? We would write 10 times 30, that's 300. All right, we're going to square root that. That's 3 times 100. 100 is actually a perfect square of 10 times 10. So that's going to be 10 square roots of 3. All right, let's try this one, 2 and 8. All right, so 2 times 8, That's 16. We square root it. That's 4. Okay. These are not staying the same difficulty each time. Okay, so now we're going to do 8 and 9. So that is 8 times 9. That's 72. We square root it. That's 2 times 36. Oh, 36 is a nice perfect square of 6 times 6. So we get 6 square roots of 2. All right, so now that we've tried out geometric mean, let's talk about some corollaries to our earlier thing. So based off of what we actually have 3 different geometric means that we can get from that. So the altitude that is in the middle of the original right triangle, so h in this case, the height, h squared is going to be the geometric mean of the 2 parts of the hypotenuse that are split. So x times y is the same as h times h. Now a, one of the actual legs of the right triangle, is going to be equal to the part of the hypotenuse times the whole hypotenuse. It's the geometric mean of the part of the hypotenuse times the whole hypotenuse, whereas b is the geometric mean of its adjacent part of the hypotenuse, which is a different part, times the hypotenuse. So let's actually try this out. So if I wanted to find x, well, x squared is going to be equal to 36 times, well, we actually need to know what this number is. So that's going to be times 64. Okay, so 36 times 64. I can put that in a calculator, but I'm actually not going to, because we would square root it, and this would just be 36 times 64. That's 6 times 6, that's a pair. 8 times 8, that's a pair. 6 times 8, 6 times 8 is 48. You can do it in the calculator and make sure I'm right. Okay, so here we have it. We're looking for a leg. So a leg squared, so x, oh wait, let's get this into a nice thing. X squared is going to be the portion of the hypotenuse times the whole hypotenuse. So that's going to equal 9 times 25. Now, once again, we could go and actually multiply 9 times 25. We'd end up getting 225. But here's the secret. Whenever we start square rooting it, which we would, this is going to be 3 times 3. That's going to be 5 times 5. That's a pair of 3s. That's a pair of 5s. X is going to end up equaling 3 times 5, which is 15. All right. Ooh, this one's a little bit weirder. Okay. So we need to figure out what the length of x is. But to do that, we actually have to figure out, I'm going to call it y right there. Because in this case, 6 square roots of 85 is equal to 36 times, in this case, y. So now we want to square each side. So 6 square roots of 85 squared is 36y. Well, 6 times 6 is 36. 85 square root of 85 squared is 85. And that equals 36y. That means y is 85. But remember, x is that whole distance, so we would do 36 plus 85. So let's see, 6 plus 5 is 11. So that's 121. All right, so in this case, we're doing the exact same thing. So 48 squared is equal to 64 times, I'm going to say y again. Oh, so let's see. This one, unfortunately, I kind of see it, but I know most of you wouldn't, so I'm just going to put it into the calculator. 48 squared is going to be, let's put it in. So 48 times 48, and that's going to equal, whoa, 48 times 48 is 2,304 is going to equal 64y, and then I divide it by 64, and that gets us 36 equals y. So there we go. So 36 is equal to y. 36 plus 64 equals 100. There we go. So exciting. All right, let's find x, y, and z. This one's going to take a little bit of extra time, but it's actually hopefully not all that difficult, other than just none of these numbers work perfectly. So we're going to start with talking about x. X squared is going to equal one part of the hypotenuse times the other part of the hypotenuse. So x squared equals 20. We square root it. That's 2 times 10. That's 2 times 5. So that means x equals 2 square roots of, gross, equals 2 square roots of 5. Now let's talk about y. So y squared is equal to 10 times the whole distance, or 12. So y squared equals 120. We square root it, 120. That becomes 2 times 60, which is 2 times 30, which is 2 times 15, which is 3 times 5. Okay, we had one pair. All of these don't end up mattering, meaning y is equal to 2 square roots of 30, because that's where we could last break it down and get a pair. Finally, we have z. Z is equal to 2 times 12. Z squared is. So then so z squared equals 24. We're going to square root it. That's, as we just established, 2 times 12, which is 2 times 6, which is 2 times 3. We have one pair. This part doesn't matter. 2 square roots of 6 is z. And there we go. So that is how we would solve all of this and find x, y, and z. We have one last question. A surveyor positions himself so that his line of sight to the top of a cliff and his line of sight to the bottom is shown. What's the height of the cliff to the nearest foot? So this is how we could figure out the entire height of the cliff. I'm going to call this part y. Our whole thing that we're out to find is z, but we'll do that in a second. So 28 squared is equal to 5.5 y. So I would just do 28 times 28. That gets us 784 is equal to 5.5 y. Divide it by 5.5, and that gets us 142.54, repeating. So that's going to be y, which means, 142 plus 5.5, that ends up being, okay, so that's 40. That's going to be 148.04 repeating feet total once you add the 5.5. So there we go. And that is it for today. You can already guess what I'm about to tell you to do, because it's what I always tell you to do. Like and subscribe. Please make sure that you like and subscribe this video. Tell all your friends about it. Tell them that finally you got to learn about the geometric mean, the thing you've been dreaming about for years. Thank you all very much. Have a wonderful day.